That's true. 6-2, number 2. Here we go. Bob, the dump truck driver, 15,500 kilograms truck included, is heading down the road with a speed of 16 meters per second, ignoring the stationary station wagon owned by the stationary store where they sell stationery. The mass of 3,550 kilograms, stationary station wagon included. After collision, Bob is shoved 15 degrees to the right of straight ahead with a speed of 15 meters per second. What is the speed direction of the formerly stationary store, stationary station wagon immediately after the collision?
This wouldn't be as bad if it was normally written.
Bob?
Why would you actually?
There's stationary station wagon station. Well, there was one year where I kept typing stationary in wrong. So I'd say that the vehicle is stationary, and they said, "Oh, it's gone wrong again." So I wrote this problem to deal with the malcontents, the troublemakers. But shouldn't say that while it's being recorded. Hey, 15,500 kilograms. This is 3,550 kilograms. Initially, this car is traveling at 16 meters per second. And it collides with stationary. We got that. All right, so Bob is shoved 15 degrees of right. So I'm going to do an overhead view. Doesn't matter which way you set this up, but I'm going to make an overhead view. So an overhead view, Bob would be going this way at 15 degrees at 15 meters per second after the collision. So the question is, where does the stationary station wagon full of stationary go? Initially stationary station wagon, but now it's moving. If I'm going to do this problem, the first thing I'm going to do, I told you this before, I'm just going to write a V this way. Now, if I get this wrong, and likely that is right? If you think about it, that's probably the direction it's going to go in. But if I get this wrong, all that's going to happen is my Vx, my Vy are going to be negative. I'm going to have to redraw. Oh, well, I can live with that. The shame is short-lived. And this way I keep things steady.
So wait, if you get it wrong, it would just be a negative.
You just get a negative value, so now it goes the other way. That's okay. I live with that. All right, so we're going to start off in the X direction. In the X direction, I've got momentum before was 15,500. Actually, let's write momentum before equals momentum after. Momentum before equals momentum after. So momentum before is 15,500 times 16 equals, this one has none, right? Peter, okay if I don't leave a zero, I don't write a zero on this one? Yeah, makes sense. Okay. So now I got to do this one, and now I got a problem on my hands because this has got components to it, does it not? And how do I deal with components? I draw them in and calculate what they might be. Okay? So try to figure this out. This side over here is going to be 15 cosine of 15 degrees. By the way, for most of you that have trigonometry, if you want to use r cosine theta, r sine theta at this point, it would be perfectly appropriate for you to be speeding along and doing that in your head. That you don't have to actually draw cosine equals this over this. Rumor has it trigonometry is finally caught up to physics on that particular item. 15, let's see here. What's my angle? Angle. I gotta check to see my mode. I'm in degrees. So now I'm going to go 15 cosine of 15. And that means my x component is 14.49. Is that okay with everybody? 14.49? So that means I'm going 15,500 times 14.49. Great?
Wait, where's the, why is it, oh, and then you're going to add the stationary?
Plus, I'm going to add the 3,550 and its velocity in the x direction. Can I solve this, Beastie?
Yes.
Yeah, so let's solve it. So I get 15,500 times 16. 2481230 equals 15,500 times 14.49. 224,595, something like that, plus 3,550 Vx. So I've got 248,000 minus that answer. And I get 23405 equals 3550bx. And I got velocity in the x direction is 6.59 meters per second. Agreed?
6.68.
Oh. Did I do something wrong? I'm liking my answer. How about 6.59? Anybody else get 6.59 or 6.68? What are we getting?
6.59.
So we equally split amongst the two choices.
Can we
Interesting.
just round it?
It feels like a rounding issue, but that's what?
I got 6.59.
I'm going to go with 6.59. My guess is it's a rounding issue, probably something right about here.
Wait, what's the other answer?
6.68. I mean, it's virtually the same answer. We're talking about 9/100ths difference. It's probably just a rounding, some zero number getting changed or something else. Or I wrote it badly over here or something. I don't know. Anyway.
You? Are you doing badly?
Yeah, no, I never do that. Okay, then in the y direction. Let's do y direction. So now I'm going to lift this thing up a little bit, give myself a little more room. I'm going to go y direction. In the y direction, I need a different colored pen. So in the y direction, what's my momentum before? 0. I got nothing going up or down before. Left or right in this case. I got nothing going left or right. And then to figure out this component here, I got 15,500 times this component right up here, right? So since that's the case, I'm going to go 15 sine 15. And I get 3.88. Does that make sense? Meters per second. So this is just 3.88. Plus, wait, I just did that wrong.
Yeah, wait.
Tell me what's wrong. No, what?
Oh, wait.
It's the other direction.
Other direction. So I'm going to put a minus on that one simply because I drew it downwards. One of them's got to be negative. And then the other one would be 3550 times velocity in the y direction. So I got 15,500 times that one. So I get 60,176 equals 3550 by. So I get Vy is equal to 16.95. Yes, sir.
Why? So that means that it's going mostly up.
Yes.
Why would it do that?
It must have just clipped the corner of this thing. Because if you look at it, whatever the pickup truck, it's going 16, it's still going 15 and slightly deflected. So it must have just clipped the corner of it. The only way this would make sense in a kinematic sort of way, right? Because it must have clipped it, and it must be being basically shoved to the left apart.
Okay.
And it's quite a bit bigger.
Okay.
Okay. All right, so far so good. And then how do I finish this problem?
Pythagoras and stuff.
Pythagoras and stuff. So I got 6.59. I've got 16.95. So that's where I redraw it. Uh-oh. Kelly? Question? You're good? Okay. Squared plus 6.59 squared square root of 18.2 meters per second at, not to give it to you this time because I asked for velocity, speed, and direction. I'm even trying to force you to say direction. So it's 18.87 meters per second, 18.2, sorry, meters per second at what direction? How do I get that?
Left.
And
Arctan. So tangent of theta equals 16.95 over 6.5. That's really weirding me out. Did I really do that right? 5.9?
68.5.
So theta equals, what'd you get?
68.46.
So 5 degrees. So I would say 18.2 meters per second at 68.5 degrees.
Up.
Left Left, because the down was right? So that'd be left of, is it east?
Straight ahead.
They didn't give it to us?
Yeah.
Straight ahead. Left of straight. Does that make sense? Painfully so?